How do you forget a calculator to a math class? Oh, that's right, you drag yours to the file. Yeah. So you really?
But I
Wait, so we don't need anything from you?
Nah, you really don't. What I want you guys to think about is when you first worked with graphing, remember what we did to graph stuff is we always made tables. Do you agree? Yes. It doesn't change when we start looking at exponential stuff. So let's just pick easy values of x and go off it. So, I don't know, 2, 1, 0, -1, -2. And we're going to substitute in those values for x and see what we get. So you have 2 squared, 2 to the first, 2 to the 0, 2 to the -1, and 2 to the -2. And that's going to spit you out y values. Bless you.
Thank you.
What's 2 squared? It's okay, you can say you thought about it, you weren't sure. What's 2 to the first? 2 to the 0, 2 to the -1. Good, you remembered something. And 2 to the -2. 4. Okay. So basically what's happening here is that if you go to look at a plot of this, it's kind of the relative, the Diplodocus, the dinosaur. Hippopotamus.
That's not enough.
Jokes don't get any better second semester. Or for you, the 4th semester. Isn't that exciting? No, she hasn't been in this class before. This is her 4th semester with me. You're like,
That's my 16th. Sure.
You're ready, buddy?
at bottom.
You are.
Wait, on the graph of my calculator, it doesn't show the second half. It only shows this part.
Oh, let's wonder why. Think about what's happening. Every time that you raise it to the negative power here, what's happening?
Oh,
It becomes 1/8, 1/16. It's getting smaller and smaller and smaller, isn't it? Is it ever going to touch 0? No. No. So what occurs when as it's approaching 0? If it's getting infinitely closer and closer to it, but it's not going to hit it. What is that? Asymptote. Good. So what's happening here on this graph is you get this horizontal asymptote that's going to occur with these exponentials. Okay. We're going to have horizontal asymptotes. Will there be a vertical asymptote? How? No. And why?
Because
It's going to go on forever for both directions. Is that your domain or range? Is your range all real or is your domain all real? Correct. The domain here, all x values are going to be fine for this problem. Okay. All of your x values in this case are going to be fine. It's just going to infinitely grow and grow and grow and grow. No matter what, there's always going to, you can still continue this graph upward, if you will. This graph is always going to get closer and closer and closer to 0, but it's never going to touch it. That's where the asymptote comes in on the range. Okay? So this doesn't look awful. I hope. So take a second, put those 3 graphs in your calculator. Do you guys want to put 3 graphs at the same time in a calculator? Do that. Do that. And see if you can see if you can notice anything that's happening. I should probably get my calculator out.
what were they?
3, 4, and 5 the x?
Yeah, 3 of the x, 4 of the x, 5 of the x.
Go to the graph.
Yeah. So both you guys forgot your calculators from math class?
Yeah. No, I placed it on my log.
The domain in this case would be all real because the x values, there's no change on the x values, there's no restriction. The range is bounded by that 0. You're not getting anything smaller than 0 in this case.
But it is.
Does that make sense? Can't make it the first day of the second semester, I tell you, kids.
I started pretty early.
Why is it loaded?
I'm so nice.
There we go. You look weird about it.
Yeah,
in for a couple of days a week. Just yesterday, he goes, "You have hair." Thanks, Dad. Was it 4 to the x, 5 to the x?
Yeah.
3 to the x, 4 to the x, 5 to the x.
So when you guys looked at these three graphs, what can you tell me about them? They're all similar.
They go up.
What's changing as the numbers change?
The angle.
How steep it is, the steepness, how the rate of increase. All right, that average rate of change is different. Yeah, it just changes up that way. Does that asymptote at 0 change at all? No. Still bounded the same way. So as you get into these things, what you're looking at here are what are called the parent graphs of exponential growth functions. This is the parent graph of an exponential growth function, where b is going to be greater than 0 and it's not equal to 1. Okay? So it's b to the x, 2 to the x, 3 to the x, 4 to the x, 5 to the x, and so on. Why don't we say it's 1 to the x? What do you think would that graph look like? Yeah, it'd just be a line. Exactly. All right. So this is your exponential growth model. But notice I'm calling it the parent function, because what do you think we're going to do to this eventually? Shift it. We're going to shift it. When we shift it, what do we do? H's and K's. So we'll have H's and K's to it. So as you go through this, and you guys have already found these things out, what was the x-intercept of this parent function for all of these? Excuse me, the y-intercept, I'm sorry. What was the y-intercept for this parent function for all of these? 1. Notice, when your y-intercept occurs, what's the value of x? It's 0, isn't it? What is anything to the 0 power? 1. So for the parent function, your y-intercept was always at 1. The y-intercept was always 1. Was there an x-intercept for any of these? No. On this one here, there was no x-intercept because the asymptote occurred at x equals, or excuse me, at y equals 0. Right? The horizontal asymptote was where? It
0.
was at 0. Is it x equals 0 or y equals 0?
I got it.
X.
Y. You guess I turn out.
Baby steps, right? Baby steps. Domain. What's the domain for
What
these?
about the vertical asymptote?
All real.
There isn't one. There's no vertical asymptote here.
Good.
And then your range? There's no vertical asymptote here because are you ever dividing by 0 in this case? No. There's no denominator. So we don't have a vertical asymptote. What happens in these graphs, granted they're all going up like this, it's not approaching some boundary on one side. There is no boundary there, okay? It's not bounded. How do I say this? It's not bounded on the right side. There's no right side boundary, okay? So there's no vertical asymptote that's going to occur. It's always continuously increasing in this case. All right, does that make sense? All right. Now this is, all these little bits and pieces are going to occur for all of these parent graphs, no matter which one it was. 2 to the x, 3 to the x, 4 to the x, 5 to the x. Every one of them has the same start. From those starts then, that's when we add our shifts. Okay. You'll see really fast how easy some of this stuff works out. This then becomes the shifted form of an exponential growth model. Okay. This is your shifted form of, here's your parent, who's y equals b to the x. So when I'm looking at a shifted form of that, notice we entered in an A, an H, and a K. What do you think the A value is going to do? Yeah, it's like the multiplier. The A, if you want to think of it, remember when we talked about it with, it changed the amplitude, remember how it changed how fast something was increasing or so? That's still kind of what the A value does. Okay? It changes the height of it if you want to think of it like that. All right? What do you think the H and the K does? Which way does H go? Right, left. Horizontal, H, and vertical. You learned something. You remembered something. I don't think that was on the line. What's that? Hey, it's better than the alternatives. Look at that. It could be worse. So when we're dealing with this, whoa. How do I say that? Think of it as an amplitude, yeah. Amplitude comes in, the word amplitude becomes more prevalent when we deal with trig, but I like how you're saying it in terms of height. Think of it in terms of height. H is your horizontal. And then K is your vertical shift. Notice how it's x minus h. So if the exponent was x minus 3, or am I moving it right or left 3? Correct. If it's x plus 3, it would be correct. And then the k value is just always as is. Correct. It's as is. It mirrors what we've been working on. The h and k values, it just mirrors the same way as it was before. This shouldn't be very difficult to distinguish between the two. Let me show you an example. Wait. Oh, I was just waiting. No big deal. Let's look at this. Did you guys all get graph paper going back yet? I had some up in the front here. You guys want to start grabbing some graph paper? So what we're going to do here is we're going to do the same thing we were doing last time when we did parent graphs and we shifted off the parent. Still going to do that. We're always going to plot our parent graph, do a dotted line, and then shift it with a solid line. It's so much easier to be able to visualize it in this method. Plus that way you don't have to worry about using calculators. Which means calculator, non-calculator. All right. So what's your A value? Half. Okay. What's your H?
0.
And your K? 0.
Wait, where would they be if it wasn't 0? Like, what would be
It would look like that. We're just baby steps. Okay. So what is your parent function for this graph?
3 to the x.
3 to the x. So my parent graph would be 3 to the x. Now, we're going to use really easy numbers. Again, 1, 2, -1, -2, things like that. Make your lives easier to work with. So if I use 3 squared, what do you get? So if I have x equals 2, 1, 0, -1, -2, that's going to give me 9, 3, 1, 1/3, 1/9. You guys agree on that?
Yeah.
Easy points to plot.
Yeah.
Okay. So at 2, it's 9. 1, 3. 0, 1. -1 there. And I know it gets tough to plot the other ones, but you can get the general idea. Everybody okay with that? Okay. Now, excuse me. Those being our parent plot points, what do I have to do to all of those?
Connect them with the dotted lines.
Connect with the dotted lines, okay. Oops. Is everybody okay that we have a horizontal asymptote at 0 right now?
Yeah.
Let's throw that in for right now. So that's my parent function. What does everything on there have to multiply by? 1/2. Okay. So if you start to think about what's going on here, as you go into your table for making this the real one, since the a value is the only thing that's changed, you're just multiplying all of those y terms that you just plotted out by 1/2. There's no horizontal or vertical shift. Okay. So now, instead of being at 2 and 9, it becomes what? 2 and 4.5. 1 and 3/2, so it would be 1.5. Now what's my y-intercept? Half. And then obviously these other points become a little bit more difficult to get to. What we did here is we just took all those points and multiplied it by the a value. That's all. Okay. This a value in the shifted function, notice what the a value became. What did it become? It's the y-intercept. Your a value, what's that? Your a value becomes your y-intercept.
Does it always do that, or?
On the, when you're h and k here,
Nothing.
right. Yes. Yeah, we're in. Right. So notice what, bless you. Is that a sneeze or you just laughing? As we get into this, the more that you go through these, you're going to plot, since we did one without an H and a K in this case, you want to plot stuff that are easy to work with. And then once we start throwing H's and K's in, that's when things get a little bit messier. Okay? Yes, ma'am?
So when you have H's and K's like this, like say this one had H's and K's, would you multiply the parent by 1/2 and then do the H's and K's? Or
Yes.
do the H's and K's?
Yeah. And I'm going to show you a little trick to that here in a second. Okay? I'm going to show you a little trick to that here in a second. Oops. All right. What's my a value now?
Negative
1.
one.
Okay. And then it's 3/2 to the x. So my a value is -1, and it's 3/2 to the x. So there's no h and k again, so we're just going to leave this written out. And we'll just move this for a second. From the last problem without an h and a k, bless you. Thank you. Do we all agree that that your y-intercept is at a?
Yeah.
So what I want to do now is I'm going to start to plot that to start. And this is where you were going with Izzy. By plotting the value of ab to the x, the shift becomes easier. Because instead of doing just the b to the x, and then doing ab to the x, and then shifting things over, by doing it right off of that, it becomes a little bit easier to do. Okay? So in this case here, I've got funky values with the fractions. You agree? So if I want to pick something out, I know that's going to be let's do -1 times 3/2 to the x. We can still pick out as 2, -1, or excuse me, 2, 1, 0, -1, -2. It's not that bad. Okay. If I use 2, 1, 0, -1, -2, just -1 times 3/2 squared. We should be able to do that. 3/2 squared is what?
9/4.
Times -1 is? -9/4. You okay with that? 3/2 to the first power is what? 3/2. Multiply that by -1, you get -3/2. 3/2 to the 0 is 1 times -1, -1. Now, 3/2 to the -1. It, 2/3, yeah, it's 2/3. That whole fraction's not happy, is it?
Oh, yeah.
So you flip it. Oh, this is a negative exponent. Negative exponent on a fraction, you flip the fraction. So it becomes 2/3, so it becomes then -2/3. Which means the next one would be good. Now I know it looks weird because of the fractions, but remember, in essence, they're not that bad. Okay? It's a matter of plotting them. Here we know we have a I know I have my y-intercept at -1. At 1, it's at -1.5. At 2, 9/4 is a little bit more than 2, correct? Up here. And then it's going to -2/3. More nice. This graph is just going the other direction. Where's its horizontal asymptote?
Negative. Or
It's still 0, yeah. It's still at 0. It's still at 0. The horizontal asymptote is still at y equals 0. Because you're going to get infinitely closer and closer and closer to 0. Now, this is still exponential growth, even though it's going the other direction. And there's a reason for that. I'll show you here in a second. Because of what? The reason that it's going the other direction is because of the negative. Yeah, that's the reason why it's going down and to the right. The other ones were going up and to the right. This one's going down and to the right. That's your exponential growth. What do you think exponential decay looks like?
left.
It's going up and left, or down and left. Does that make sense? And there's a reason why that happens, and it has to deal with the value of b. Okay. Not so bad so far? Let's do it. What's up? Yeah, because there's no H or K here. We just grab the parent. This would be the parent.
One before didn't have an H and K in their parent.
The reason I did it that way is because I was slowly showing you guys what that value does, what the A value does when you plot that into it. And you notice how in this case the A value just became like a multiplier of it. By using order of ops, it became the new y-intercept. Yes, ma'am. No, because I'm going to start doing just the straight parent off of that. Okay?
Isn't the parent though 3/2 to the x?
Yeah.
The b to the x is, but as we get into this more and more and more, graph that first. I'm saving you a step.
Alright.
That's all. I'm just saving you guys a step by not doing 3 graphs on one. Because when we do the H and K here in a second, we plot it off of that anyway. It's just a little bit cleaner. I was just taking a second to show you what happens with A. Why is it important? That's why I did that extra step a minute ago. That's all it was. All right. I won't do that next hour. Obviously, lose my Am I right or am I right? Yeah. You okay with that before lunch or earlier like this? All right, I'm just worried about you. That class is gonna be really small.
What class?
6, 7.
Well, did people drop?
A lot of people shifted classes, so there's like nobody in my class that shifted. Shifted. It's a play on words. It's funny because it's true. I should put the clutch in now. Really? Nobody?
What?
I like having a small class.
I'm sorry, I got it.
Go figure. All right. So let's start out with labeling our A, H's, and K's. What's my A value here? 3. What's H? 1, because it's minus 1. And then what's K? -4. Good. Which means all of my parent function ordered pairs are going to go where?
Right one down 4.
Right 1 down 4. Perfect. So as we start this out, just like we did with our parent functions before, let me just move this a bit. We're going to plot y equals a b to the x. When you do that by bringing in your a value, we now know right off the bat where the y-intercept is. That's why I want to use this a value. Okay? I'm going to use easy values again, 2, 1, -1, -2. So 3 times 2 to the -2, 3 times 2 to the -1, 3 times 2 to the 0, 3 times 2 to the first, and 3 times 2 to the square. We okay with that? So 2 to the -2 is what? 1/4 multiplied by 3, you get 3/4. Next one, you get 3/2.
Yeah.
What's the next one?
3.
3, good.
Okay.
What's the next one?
6.
6
Yeah.
and 12. Everybody all right with that?
Yeah.
Okay. So when I plot this, when I start my plot, we're always going to plot the parent graph. The parent graph, when we have shifted exponential growth, exponential decay, and eventually we get to logarithms, it's the A and B, which is usually what we're going to start with. H's and K's come in after that. Okay. So at -2, we're at 3/4. -1, we're at 3/2. At 0, we're at 3. At 1, we're at 6. And at 2, we're up here at 12. Where's the, yes sir?
So if x is -2, why is it 3 times 2 to the -2, not,
Please excuse my dear Aunt Sally.
but like why wouldn't it be 3 times 2 to the -3?
Please excuse my dear Aunt Sally.
I don't know.
10 does.
Yeah, but.
What comes first? Exponents or multiplying?
Yeah,
Exponents.
exponents.
So you have to take care of the exponents before you multiply. So your order of operations tell you go 2 to the -2, which is 1/4, then multiply it by 3.
Okay,
That's all. So that's why I was saying, please excuse me.
yeah.
All right.
Yeah. Yeah.
You don't remember that?
I do remember it, but I just wasn't sure how I.
That's
my
yeah.
motto, that's why. Wake up in the morning.
I feel bad for your Aunt Sally. Anyway, so there's your parent graph. Where's your horizontal asymptote to start with? Y equals 0. If your parent graph has a y equals 0 horizontal asymptote, what do you think is going to happen to the horizontal asymptote when you shift it?
It's going to go
Goes
the
down.
same direction that you're going.
Correct. The horizontal asymptote gets shifted just as well as the H's and K's do. Which value, H or K, moves the horizontal asymptote?
K.
So we know that we have a new horizontal asymptote at y equals -4. Let me change color. Excuse me. Are we okay with that?
Yeah.
To each of these points, then, all I have to do is move them right 1, and down 4. Right 1, down 1, 2, 3, 4. Right 1, down 1, 2, 3, 4. Right 1, down 4. 1, 2, 3, 4. So then it would be, it's at 12, 11, 10, 9, 8. And remember when we did this before, when we walked through the ordered pairs? Remember how we would do the x plus 1, y minus 4? We would do that and add them out. It's the same basic idea. When we did that before, when we wrote out our shifted stuff, sometimes you guys thought it was really easy just to write out your ordered pairs with the shifted thing. You can do the exact same thing here, and there's your new graph. And that's a shifted exponential growth function. Okay. That's so scary for the first day start out.
So what's the new horizontal asymptote?
The new horizontal asymptote is at y equals -4. Because remember, your original asymptote's at y equals 0, so your k value becomes your new horizontal asymptote. And that's something you can always count on. That's always going to happen. All right? We okay?
Wait.
Let's try one more. I think we might have to do decay stuff tomorrow. There's more of the decay stuff tomorrow. But let's see what it goes. So what is it? If it was 0, 1.
I said 0 like that's not right.
Yeah. Good catch. Good catch. So let's look here. We've got y equals 2 to the x minus 3, all plus 1. Now in this case, what's going to be our a value? 1. Good. So the a value here is going to be 1. What's your h?
3.
And what's your k?
1.
Okay. What is going to be your parent graph that you're going to plot? 2 to the x. So 1 times 2 to the x. A to the x in this case, if you want. And I think we had these ordered pairs earlier. What's up? Good conversation.
Yeah.
So we had, what was it? 1/4, 1/2, 1, 2, and 4. That's what we had for this one, correct? Notice your y-intercept is where?
1.
1 again. -2 1/4, -1.5, 1, 2, 4. Excuse me. And to each of those points, what do you have to do?
Right, 1. Or left.
Is it left or right? It's going to be to the right. Is x minus 3?
Oh.
So now where's your new horizontal asymptote going to wind up?
2, 1,
Which is
4.
1.
I've heard 2, 1, 4, 3.
Y equals 1.
Y equals 1. Good. My new horizontal asymptote is going to wind up here at y equals 1.
Oh, I thought you were asking about the intercept.
Oh. There's my new y-intercept. My, let's see, so we go right 3, 1 little, 2 little, 3 little spot, up 1. And there you go. And yeah, you're.
Do you even have a y-intercept for the second one?
We do. Your y-intercept for the second one is when x is at 0.
Oh. Oh, yeah, okay.
So your y-intercept in this case for your shifted graph is when x equals 0. So it's 1/8 plus 1, so it would be at 9/8. Does that make sense?
Yeah.
Did everybody hear that, how I figured out the new y-intercept? It's still at when x is equal to 0. So if you substitute in 0 for x, you get 2 to the negative third. So that's 1/8. Add 1 to it, you get 9/8. Everybody all right with that? That's your new y-intercept. Let's do this. We're going to have to cut this in half because I don't think we got enough for k problems, which is fine.
Gross.
Yeah, you like that?
That's kind of
It does quite often.
I was thinking US history.
Let's do this top chunk. All right? Just do this top part for now. We'll work on those for tonight. We'll continue to look at the difference between growth and decay tomorrow. Tomorrow should be a little bit easier because it's the same exact thing, just one change. So it won't take as long to get through. So we'll probably get to homework time a little bit quicker tomorrow. All right. This stuff is already uploaded online. The book is back up there again. It's all ready to ready to go. All right. Yeah. You want more graph paper? There's more graph paper floating around. There's a ton of it in the back there. Okay. Do you guys need more graph paper? Oh, I'm sorry. Okay, you get paper. I feel that.
Oh, it's like